Okay, so this is an example of a cylinder, okay? As we talk about a cylinder, I'm not really worried about you guys doing this warm-up. All right, so this is an example of cylinder. And if you understand volume has more to do with what, if I was to figure out exactly how much space the inside of this cylinder occupies, that's an example of volume, right? Okay, so if you look up here for the example up here, okay, if we fill this jar with marbles, okay, you could estimate how many marbles are in the jar, okay? Now, this wouldn't be an accurate representation of the exact volume. Why? Because there's space, right? Okay, it's not taking up all of the available space inside of that, right? Okay, so what do you think is a good indicator of, or a better way to measure volume? Water or liquid, right? Because there's not extra space in that. Does that make sense? Okay, all right. So first of all, what is a cylinder made up of? What is this made up of? It's basic. Okay, check it out. If I cut this cylinder right down the middle like this, and I unfolded it, okay, without worrying about what this and this are, okay, if I unfolded this, what would I essentially have? A rectangle, okay? I would have a rectangle. And then I would have also what? Two circles, right? Okay. So before we get to that part of it, okay, let's take a look at some of the stuff that we're going to need to know, okay? You're going to need to know what a cylinder is and what volume is. Well, we already talked about it, right? A cylinder is basically a rectangle, an enclosed rectangle with circular tops, circular bases, right? And volume is how much space an object occupies, okay? So if we talk about volume of a cylinder, let's first take a step back and find, if we can remember. Does anybody remember how to find volume of a rectangular prism? If I wanted to find volume, let's say of this Kleenex box, okay, the volume of this Kleenex box. Does anybody remember the formula? It was pretty easy. Anybody remember? Andrew?
Isn't it like length times width times height?
Length times width times height, or base times width times height. Now, think about this. How many things did I multiply there? Three. Okay, how many dimensions are there on this?
Six.
Dimensions. How many measurements are there? There's three. There's length, there's width, and there's what? Height. Okay, good. What about a triangular prism? Does anybody remember a triangular prism?
Well, isn't it the same? It's like base times width times height with a half.
Yeah, you divide it by 2, right? Or multiply it times a half, right? Okay, good. I'm not going to go over that kind of stuff. So as we look at cylinders, okay, first of all, if there are circles involved, what do we know? What part of that circle is going to be important? Is the circumference really important right now?
No.
Not for volume, okay? But what do I need to find the area of a circle? The width of the circle, which is also known as the what? Diameter. But technically, I don't really need the diameter. If I was to find the middle of the circle to the outside, does anybody remember what that's called?
Radius.
Radius, good. So I need a radius in order to find the area of a circle, right?
Yeah.
How do I find area of a circle? Area equals pi r squared. So pi times the radius squared, okay? Now, there's another dimension here, okay? That sounds funny, huh? Imagine, if you will, another dimension. There's another dimension of measurement we're talking about on this, okay? That's going to determine the volume. Think about this. We've already got the circles taken care of, right? But, okay, if I cut this cylinder in half, like right here, is it going to hold less? Yeah, right? If I was to extend this, okay, keep it going, is it going to hold more?
Yeah.
So what am I talking about here?
Volume.
The height. The height of this cylinder is going to have to do with the volume, okay? So the first examples we're going to look at are the ones that have a radius, okay? So if we are given a radius, okay, the first thing we're going to do is write the formula. Look at this. If you'll copy this down, please. Okay, or just, it's hard for you to copy down. If you can just write the formula. Okay, volume, write this down. Volume of a cylinder, V equals, ready? It's not up there. V equals pi times radius squared, not pi r2, pi times radius squared times height. Pi times radius squared times height. Okay, now let's look at this figure. Okay, I'm given a radius here, so pretty much all I have to do when I'm using that formula is plug the numbers into the right places. What's going to go in place of the radius, the r? The 5. What's going to go in place of the h? The 8.3. That's the height of the cylinder, right? Okay, so we write our formula. Okay, volume equals pi r squared times height. Now, you have to be kind of careful. Okay, I know you're using calculators for this, but if you just plug everything into your calculator at once, sometimes your calculator kind of jumps the gun a little bit and does multiplication prior to doing an exponent. Okay, would that mess you up here? Think about this, guys. If I multiplied pi times the radius first and then did the square, am I going to get an incorrect answer? What do I, according to order of operations, parentheses are first, what comes after parentheses? Exponents. Well, what is the exponent attached to here? The radius, right, or the 5, right? That's the only thing we're concerned with, okay? So what we need to do first, let's take care of this 5 squared, okay? Then we can multiply everything else, okay? What is 5 squared? 25. Okay, so this would be 25. You can write this down. Okay, it's kind of skipping a step here on this example, but you can write this down as you put it into your calculator. Everybody have a calculator with you? Okay, plug this into your calculator. 3.14, every time we see pi, we're just going to use 3.14, okay? Because if you press a pi button, different calculators determine pi to different lengths. Does that make sense? Okay, because pi is an irrational number. It goes on and on forever. Okay, but some of your calculators might stop pi at the 10 millionth digit. Some of them might stop pi. So the way that we keep consistency is just to go use 3.14. Okay, now, anytime pi is involved, are you going to come up with an exact answer? No. All of your answers when you're using pi should not be equals. What should they be? About. Okay, and if you remember, that's an equal sign that's kind of curved, right? Okay, about or approximately. Okay, so multiply this. 3.14 times 25 times 8.3. Now, what did we do here? All we did up here is we did 5 squared times 8.3, and we got 207.5. It's the same thing, okay? The order of multiplication doesn't matter. That's the commutative property, right? It doesn't matter what order I'm multiplying. But when there's an exponent involved, I need to take care of that exponent first, okay? How many of you got that? About 651.9. Now, you might be slightly higher, slightly lower, because you're estimating, or you're not estimating, but you're rounding pi to just 3.14, okay? Now, I shouldn't say the most, but a very, very important part of this is how we label volume, okay? How is volume labeled? Cubic units, right? So what is the unit that we're talking about here? Centimeters, okay? So my final answer is going to be about 651.9 what? Centimeters cubed, okay? Cubic centimeters, okay? It's the same thing. All right. Are we good so far? Okay, you guys try this one on your own, and let's see if you get it right. Try this one. Write the formula, and then let me know when you get an answer. One of you has an answer. Okay, how many wrote the formula? V equals pi r squared times height. Okay, what are we going to replace the r with? 3. What's 3 squared? Don't say 6. 9. So V equals 3.14 times 9 times 1.8. And about what do we get? About 50.86 inches cubed. Okay. You can probably round to the nearest tenth. So instead of 50.86, that would be about what? 50.9? 50.9? Okay. If it was 100th, yes, but it's the nearest tenth. Okay, are we good on that? So you understand if we are given a radius, how to find the volume of a cylinder. Okay. Let's look next at if we are given a diameter. What is the diameter as far as the circle goes? It's all the way across, right? So if we go all the way across and we really only need halfway across, what are we going to do if we're given a diameter? Divided by 2. Pretty easy, right? And then we've converted that diameter into a radius, and now you understand how to find the radius. So if we were to look at this, and just visually, because we don't have a picture here, if we were to find the volume of a cylinder with a diameter of 16, automatically I can assume if I have a diameter of 16, what's my radius going to be? 8. So I have that in your head, and a height of 20. Now, does the height change at all? No. So if we were to write our formula, volume equals pi r squared times height, okay? We're going to replace this r, not with a 16. Is that a potentially costly mistake? It's potential. You could just read this and put the 16 in place of that r. Would that be wrong? Yeah. So let's replace that r with an 8. Okay. And volume equals 8 times 8, which is 64. Okay, times the height is 20. Okay. Do that on your calculators. Pi r squared times height, what do we get? Does that sound about right? Okay, so 0.2. And that would be what? Inches cubed. Which unit is squared? When we're finding what, do we square the units? Area. All kinds of area. Good. Okay, are we good on this so far? Easy stuff, right? Okay, now. All right, so this one, we're going to actually apply this to something. So, a metal paperweight is the shape of a cylinder. The paperweight has a height of 1.5 inches and a diameter of 2 inches. How much does the paperweight weigh if 1 cubic inch of metal weighs 1.8 ounces? So, in order to solve this, what are we first going to have to find? Not the area, the volume, okay? So if we're given this information, can you find the volume? Yeah. Okay, find the volume for me real quick. Find the volume. Okay.
Mr. Crucy, can I move up? I can barely move forward.
Sure. Okay, so we're going to say it's about 4.7. Okay, now, what are we going to do with that volume? 4.7. This says we're trying to find the weight of the paperweight. What if we go back to the first part of this question, it says, how much does a paperweight weigh if 1 cubic inch of metal weighs 1.8 ounces? Well, we figured out that the volume of this paperweight was 4.7 cubic ounces, right? So what are we going to multiply that times? We know that 1.8 cubic inch, equals 1.8 ounces. So if we multiply that times 1.8, that'll help us to determine that. And if you multiply 4.7 times 1.8, what do you get? 8.46. Good. Or about 8.5. If we round that to the nearest tenth, about 8.5. Okay? Does that make sense how we were able to use the volume to answer a second question? Yeah. Okay. All right, you guys try this one on your own. Okay, were you able to find the volume of the container? What did we use? We used a height of 48 and a diameter of 18, which would mean a radius of what? 9. So 9 squared is what? So volume equals pi r squared times height. So volume equals 3.14 times 81 times what? What's the height? 48. Now that we've found that volume, I'm going to do that real quick right here. And rounded is about about 12,208. Is that about right? Okay. Now, what are we going to do with that? It says about how much do the contents weigh if the average weight of an aluminum can is 0.5 ounces and the volume of an aluminum can is 25.5. Use the value of pi stored on a calculator. Okay, round the number of ounces to the nearest tenth. Okay, what do we get? Huh? Okay, if you divide that, what did you get? You divided that by 25.5. And we got about 478. Is that about right?
Yeah, well, then.
But then what do you have to do with that? Times what?
Multiply by
Times 0.5. Good. All right. Does this make sense? Pretty easy stuff. Okay. So let's look at this question. Okay, if we're going to apply this. Okay, so I don't want to play this video. If we are, let's just look at this, okay? We have a 20-foot diameter here, and the pool is 4 feet tall. Okay, and it wants us to find out. No, the reason I can't is if I play the video. Well, let me turn off the thing. Hold on. If I play the video,